Hello, I would like to tell you about the status and the system of eco-friendly agricultural products in Korea. Then, what is the certification system of environmentally friendly agricultural and livestock products? The system in which safety of environmentally friendly agricultural products are certified by government accredited certification bodies after the bodies inspect the products based on the strict certification standards. In addition, as shown in the figure below, the Eco-Friendly Agricultural Products Certification System provides detailed information related to organic agricultural food and processed products. Then, what is an environmentally friendly agricultural and livestock products? The agricultural products produced by using no chemicals such as organic synthetic pesticides, chemical fertilizer, and feed additive at all, or using a minimum amount in order to protect the environment and also to provide consumers with safer agricultural products. Then, this is the management of environmental friendly agriculture and livestock products. It includes strict product quality audit, which monitors the compliance of certification standards in the process of production, including soil, water, growth, and harvest, and in the process of shipment or distribution of certificate products. Furthermore, surveillance audit is carried out in order to prevent non-conformities of standards and false labels in the market. Eco-friendly agricultural product falls into organic and non-organic product, and eco-friendly livestock product falls into organic and antibiotic-free livestock products. Here, organic products are crops grown without the use of organic compounds and chemical fertilizers, and as a prerequisite for final certification of organic product, perennial crops must be processed 3 years before the first harvest and other crops for 2 years before sowing. The domestic eco-friendly agricultural products. The domestic sorry, 이거 자꾸 해석. The domestic eco-friendly agricultural products certification is divided into two grades: organic and pesticide-free. An antibiotic-free product can be also certified. You could see the label for each certification. Concentrates are divided into organic and non-agricultural products, and organic products are divided into organic and organic livestock products. Organic products is a crop grown without the use of chemical concentrates and chemical fertilizers. Agricultural and forestry products can be divided into organic and pesticide-free class. And organic products can be divided into organic agricultural products and organic forestry products. In here, organic agricultural products are that are not used as chemical agricultural products, and pesticide-free agricultural products are grown with only 1/3 of the amount of chemical fertilizer. This is the NAQS, the National Agricultural Product Quality Management Service in Korea. All organic products producing and stable distribution managing in Korea are being directed by NAQS. The organization of the NAQS has its own testing laboratory, which includes quality inspection, stability analysis, ingredient examination, and place of origin verification divisions. Korea has 9 provinces, and each province has one NAQS office. In total, 121 branches are located in all around Korea for thorough quality management service. In 2020, the certified eco-friendly agriculture land area in Korea is around 82,000 hectares, and the organic certified area is 39,000 hectares, and pesticide-free area is 43,000 hectares. The organic certified area in 2020 increased by 29.7% compared to 2019 due to organic conversion of non-pesticide certification, which was 39,000 hectares. The pesticide-free certified area in 2020 is 43,000 hectares, which is 16.8% compared to the previous year. The 8,720 hectare appeared to be reduced. Next, I will talk about the GAP system, which is a general system for managing agricultural and agricultural assets in Korea. Since 2006, Korea has implemented a GAP system to enhance agricultural safety. Here we have GAP certification labels. GAP was established by Codex in 1997 and FAO in 2003 and has been operating until now. The European Union presented GAP as a condition for conducting farming in order to acquire EU membership and through the establishment of the Common Agricultural Policy, implying that it could contribute to standards even higher than GAP for farming. So here we have EURAP, the abbreviation of Euro Retailer Produce Working Group, an organization that consists of the leading distributors of agricultural products. As a GAP system developed in Europe, EURAP GAP is broadly applied within the agricultural products distribution stage in Europe and is also a privately led quality and safety certification program that is being used in regions of Africa and Asia. EURAP GAP standards emphasizes safety in the agricultural products, production process, environmental preservation, and the protection of wildlife, which is reflected in the Common Agricultural Policy of the European Union. In September 2007, the name EURAP GAP was changed to Global GAP. In China, GAP certification standards were established to the State Council of the People's Republic of China affiliated certification, and which is CN, and Accreditation Administration of the People's Republic of China, which is CNCA, and the China Quality Certification is in charge of most certifications. In consideration of the smallness of scale of Chinese farms and the difference in features across farming regions, GAP China has established standards for first-rate certifications and second-rate certifications, and that which is recognized as being on par with Global GAP as first-rate GAP. The recognition of the equivalency of first-rate GAP was acquired in February 2019 through the signing of MOU with Global GAP. So from now on, I will explain about the PLS, Positive List System. This positive list system is a management system applied uniform limit, which is 0.01 milligram per kilogram, as maximum residue limits other than registered pesticide substances by registering the pesticide substances used in domestic and imported food and by establishing maximum residue limits. Japan, it was established in Japan in 2006. And EU 2008, Taiwan 2008, and US introduced. If the PLS system is implemented, then all components that are not registered in the work must be maintained at 0.01 ppm or less, and about 600 chemical components are targeted in Korea. According to the PLS, all the component which is not registered in its standard should be controlled under 0.01 ppm, and Korea has 600 kinds of components in our registration list. I will give you some examples of PLS application here. When diazinon, which is one of the pesticides for Chinese cabbage, is detected 0.03 ppm in chinamul, in that case, with existing law, pesticide substance detected within 0.05 ppm, which is the minimum limit of the applicable pesticide substance. So it is defined that a fit, it is fitable, like okay in the standard. But after enforcement of PLS, uniform limit, which is 0.01 ppm standard, is applied so that it is classified unfit, not okay, and should be discarded or shipping out should be postponed. And now it is the registration status of the Organic Agricultural Material Certification System in Korea. In 2021, total 1,622 items are registered as the certified organic agricultural material. And organic agricultural material consists of 5 types. Number 1, improving soil and growing crop. Number 2, only improving soil. Number 3, controlling disease. Number 4, controlling pest. And number 5, controlling disease and pest. Among these 5 types, improving soil and growing crop material has 944 items, taking up 54%, and the next is controlling pest material, which has 305 items, taking up 19%. By 2050, the world's population will reach 9 billion people, and crop production demand is predicted to double from now on. The demand of insect-resistant management is getting important due to the increased number of insects which are resistant to chemical pesticides. Bt cotton resistance is gradually expressed, which has a resistance to the in India. So the amount of chemical pesticide is getting increased, as you know. Therefore, we need to respond to 3R, which means resistance, resurgence, and residue. And for 3C, crisis for environment, crisis for food, and crisis for energy. And also, we need the products which cannot be less influenced by NTO, non-target organism. Here we have a global top 10 countries which are suffered from the pest increase because no more new mechanism type of pesticides has not been developed from 2000s. Cotton bollworm is damaging in 143 countries. Tobacco whitefly in 165 countries. Diamond backmoth in 151 countries. And green peach aphid in 142 countries. Statistics on 12 major resistant pest types. Chemicals that indicate pest-specific resistance and cases where resistance to APRD has not been reported. Two-spotted spider mite is resistant to 93 pesticides, has 414 resistant reports, and diamondback moth is resistant to 91 ingredients and has 576 resistant reports. So this graph is a data that shows the chemical agricultural ingredients obtained resistance of pest species and pests that are resistant to key chemical agricultural ingredient until 2014. There are 586 species of pest resistant to one or more chemically concentrated ingredients. The number of insecticides resistant to one species or more pest species is 325, and the number of GMO type resistant is 5. And here we have the below graph. Cumulative increase in the number of individual cases of resistance for insecticides, herbicides, and fungicides. This one is insecticides data currently provided by Dr. David Moda Sanchez and Mark Wallon, Michigan State University. Insecticides have the highest cumulative resistance to 2010, followed by fungicides and herbicides, and GMO has seen a gradual increase since it was first reported in 2000. According to Agronova's research, distribution of total insecticide sales by broad mode of action in 2013 were approximately $17 billion, and 85% of products have neuro and muscle toxicity. In addition, growth interference action and energy metabolism interference action were reported as 9% and 4% respectively. According to Agronova research, the most pesticides sold by 2013 were neonicotinoid-based insecticides with 27%, as 16% of pyrethroid-based pesticides, 8% of diamide-based pesticides, and 7% of ivermectin chemical pesticides in the same system were investigated. Like this, as long-term duplicate use of chemical pesticides, it makes more resistant to pest, disease, and weeds, so that the global major pesticides companies are aggressively penetrating into this bioagricultural field these days. We examine the period from the day that resistance was used to treat the expression of resistant to fungicide and antibiotics to the confirmation of the resistance. From 1960 to 1969, the period from start to resistant expression was very long, like 20 years and 40 years each. But by 80s, sterilization or anti-pesticide agents developed in the 2000s. Those were confirmed to have resistant expression within 13 years or less than 2 years. The mite is a damaged pest with strong chemical aeration resistance. Life begins to grow at 9 degrees, and the growth temperature is 20 to 28 degrees. 10 generations occur in 1 year, and the ratio of males to females is 3 to 1. Most females spawn about 100 eggs per month for about 2 to 6 days. And these many generations make high level of drug resistance. It is a picture of sting stillets into cells and suck the juice of the leaf. And there you can see crop damage by mites. This one is diamondback moth. Diamondback moth is the first damages the first crop pest that has evolved to be resistant to DDT insect repellent period, which is 15 to 18 days and occurs 8 to 12 generations a year. Pesticide resistance is very strong, so that the pesticide is sprayed on the first instar during the larval period, which is very important to be antisected. The big damage type of insect, which is Noctuidae. In case of this history of the Noctuidae, Lepidoptera, which is a worm and a common cutworm, and good to control when insects are relatively when controlled with pesticides. And for aphid, green pitch and cotton aphid is the most damaged insects. Um, this one has a short life cycle and very adaptive to the environment. So it has a lot of pesticide resistant acquired aphid. Thrip is very long as adult life and which is about 20 to 40 days. The development period from the egg to the adults is about 10 to 20 days. And the pesticide spraying effect is half-life during pesticide spraying because it sends a dedicated and caterpillar period in the soil after the second roundworm. The importance of using products to process in the soil due to the life history characteristics of thrip. And it also reduces pest density in advance by the medium of the various disease. This one is tobacco whitefly. Whitefly is a pest that mediates viral disease, and the pest resistance is very strong. It has a life about 16 days, spawning for 10 days, and the breeding power is very strong in order to increase the anti-control effect, which requires continuous control for 7 to 10 days. This is the end, and thanks for your listening.
What I'm gonna talk about today is agriculture crisis by climate changes and overcoming with plant physiological technology in Korea. I will divide my presentation into climate change and crisis in world agriculture, and in case of Korea, such as temperature decline and long rainy season. And then lastly, how to handle these problems. Let's start some pictures. As many of you already know, due to global warming, various extreme weather events are occurring all over the world. It threatens not only our livelihoods, but also agricultural environments that supplies our food. This picture shows drought and burn damages by forest fires. And this picture shows abnormal snow. Sometimes snowy days comes in the spring season. And this is tornado. It is common climate change in the USA. With these changes, farmers are suffered by extreme climate changes. Crops severely damaged. Farmers cannot be ready against unpredictable weather event. Nowadays, it is the worst moment to grow crops ever before. And then what about Korea? We also cannot avoid the abnormal climate events. These pictures show cold damages in the spring and flood in the summer. Recently, these two is key problems in Korea. The first of the problem is the abnormal temperature change. Temperature decline causes adverse raw yield in Korea. I would like to illustrate by showing you a graph that shows lowest temperature of 2019 and 2020. The red line is in 2020 and the blue line is in 2019. Normally, the flowering stage of apple in Korea is early of April to mid of April. In 2020, the temperature of late of March was higher than in 2019. So, the flowering stage was started 5 to 10 days earlier than in 2019. However, in mid of April in 2020, the lowest temperature went down suddenly. During this season, many of flowers were frozen and damaged. As a result, yield of apple in 2020 decreases 21% than in 2019. These pictures show flowering stage and petal first stage in 2019 and 2020. As you can see, many of plant was damaged by cold weather in 2020. The next problem is long rainy season in 2020 in Korea. The longest rainy season read low yield of rice. First graph indicate that the days of rainy season in Korea during last decade. Second graph indicate that the rice production in Korea during last decade. Average rainy season is normally 30 to 40 days a year in Korea. However, in 2020, the rainy season was the longest ever before in Korea. It was almost 60 days. As a result, we had problem with lack of essential temperature and sunshine for rice growing. Yield of rice in 2020 was the worst since last 10 years. Due to the long rainy season, rice paddy has the critical damage like rotting and rice plant fall down. Under this circumstance, how have we handled problems in 2020? In the case of apple crop with cold damage, we would like to provide solutions with a suitable technology. By applying one of our technology, first, we can help to enhance flower buds physiologically stronger. Second, activate ATP energy so that bud temperature is increased and resistance is enhanced against cold, like improving human body immune system. Thus, cluster leaf is grown faster and they can guard flower buds. Or, on the other way, reading faster growing of flower and fertilization before coming forecasted cold. Our second solution helps to prevent damage by a long rainy season on the rice farming. Rice panicle initiation stage is started on July in Korea. Panicle initiation is a critical point for increasing yield of rice. No panicle means no rice. The first efficacy of this technology is enhanced roots and body, plant body. Enhancing roots and plant body can endure the longer rainy season basically, and it also helps rice can fertilize itself for pollination rate to be increased. Thus, enhanced body is strong against rotting. The last solution is also related to temperature decline, and it is another technology applying when transplanting period. In Korea, rice growing season is May to October. Sudden temperature decline is occurred on early May in Korea due to climate change. An option to avoid loss on this period is to postpone the transplanting timing. Our technology helps ripe to be grown faster at the tillering stage. It is able to shorten 10 to 15 days of total growing period. It means able to postpone the transplanting timing 10 to 15 days later than usual in order to avoid sudden temperature drop. Today, I have shown you the circumstances that we face the damages and how to handle them in Korea. With this representative 3 technology, many farmers in Korea minimized their damage in 2020, and have been overcoming climate change. I would like to conclude this presentation with pictures of our farmers applied our technology. Thank you very much for your attention.